Telekinetic control of Android, and other wonders of the modern world. Jorge Silva, October 21, 2011. Google Tech Talks are designed to disseminate a wide spectrum of views on topics, including current affairs, science, medicine, engineering, business, humanities, law, entertainment, and the arts. Disclaimer: the views or opinions expressed by the guest speakers are solely their own, and do not necessarily represent the views or opinions of Google, Incorporated.
Right, Android's an open platform, runs on commodity hardware, runs on phones, and we all use it on a daily basis. But you will see a completely different perspective to what you can do with a device that's running an open platform and has the ability to control other things and be controlled by other things. They've been working on Android in the context of wheelchair users. They've done some fabulous work, and they also have some great ideas on what they could do in the future. So rather than stealing their thunder, I let Jorge introduce the rest of his project and wow us with the wonderful work they're doing. Thank you.
Thank you. Thank you, TV. Thank you, Charles. That's very, very kind. And as TV was mentioning, we've been collaborating on an accessibility initiative that I'm personally very... this one's working, right? Okay. Yeah, thank you. So, yeah, I was saying it's a very exciting opportunity. It has been a very exciting opportunity to be working so closely with the accessibility team at Google. And this is a project that I'm personally very passionate about. I'm here representing two organizations. One is the Inclusive Design Research Center at OCAD University in Toronto. And the other one is a startup company, Komodo Open Lab. And those two organizations basically span the full breadth of what we've been able to achieve through this project, and with the help of an open platform such as Android. So I'm going to talk a little bit about that. And as you can see here in the slide, I borrowed this from the Rapture Historical Museum, and this is an ad for plasmid that the citizens of Rapture, can purchase, and will allow them to control matter with their thoughts, right? And apparently this particular ad is targeted at people who are just too lazy to put sugar on their own coffee. There's another ad, this one for a later version, new and improved version of the same plasmid, and of course this has a little bit more of a mainstream appeal, right? It's not just lifting spoons. Now it's the ability to lift a couch and clean up, vacuum under the couch. And you know, of course, for those of you who haven't realized this, this comes from a fictional storyline that was created for the game BioShock, which was one of the most played or popular games in 2008, spanning as well to 2009. But wouldn't it be great to be able to control matter just using your thoughts? And you know, why wouldn't we be able to do even more? I mean, controlling matter is cool, but what about controlling atoms, controlling interfaces, controlling screens? Every user interface that you find out there, you know, walking to an ATM and not having to actually push any buttons at all, just with the power of your mind, the ATM guesses that or knows that you want to check your balance, or you want to get some money out of the bank, and without actually any significant effort, you can just do so. Well, of course, this is a fictional storyline. This is of course impossible. However, on September 28th this year, David Thomas, who is quality assurance analyst for a company in in a game development company based in Vancouver, created this tweet, and I'm just going to read it for you. David Thomas says, just installed Hootsuite. Is that the right pronunciation? Yeah, I guess. Sometimes my English fails me. Just install Hootsuite for Android and type this without physically touching my phone. And then he refers to a couple of hashtags, accessibility, Tecla. And this is actually the result of work that started at the Inclusive Design Research Center in the summer of 2010 as part of an experiment that was made possible by the Google Summer of Code program with a student that started working on could we actually control a phone without actually touching it? And then in 1 year or a little bit over a year, it has evolved all the way into a product that is about to be commercially released. And I'm going to explain how this all works and what this all means. But before I do that, I'm going to go and explain a very odd and very bizarre world, which is the upside-down world of disability. And this is a world in which power wheelchairs, which are basically robotic chairs that you don't have to make any physical or any significant physical effort to drive, cost more than the last car you bought, right? Maybe a couple times more, maybe up to 3-4 times more even. This is also a world in which single-purpose assistive devices can cost over $10,000 with failure rates of 50% in the last 3 months. And this is real data from the Centralized Equipment Pool, which is a program run by the province of Ontario in Canada that provides assistive technologies for people with disabilities. This is the actual failure rate for one of the most popular products they have. I'm not going to say the name, that's not the point, but its main purpose is to generate speech for people who cannot actually speak by themselves. So this will be a machine that basically shows a flat screen and a bunch of icons that people select, and they go through a few different menus until they compose a complete sentence, and they press play my sentence, and the gadget speaks for them. So they can go to a coffee shop and order a latte, or they can request a ticket at a movie theater. And that's exactly the case, right? This thing can cost up to $10,000, and it fails quite a bit. And this is also a world in which all this is requested, all this expense is requested from people who, on average, have only 72% of the income that their able-bodied peers have. That's again data for the province of Ontario in Canada, and is more or less very similar in most of the developed countries in the modern world. So obviously, as you can see, this bizarre world of assistive technology and the bizarre world of disability is expensive, is completely unsustainable, and it provides, it's buggy, right, basically, and it provides better than nothing workarounds as opposed to real effective fixes for what people expect, or for what any of us would expect. So why is this? Well, I've heard over the years, Mauricio and I have been working with people with disabilities for about 10 years now, and we've heard all sorts of reasons why this is the case. You can say, well, the market is kind of small, right? Like there's very few people using these things, so it's going to be complicated. Specialized equipment is required, and that's expensive. You have to customize things to fulfill the needs of these users, and that takes time and that takes effort. There's also a high risk. There's a lot of liability issues involved. But I think all of that is kind of looking at the problem from the wrong end of the spectrum, right? You're looking at the problem once it's already there, right? Once it has already been created. Yeah. So of course, yes, if people can't use a particular interface, if people can't have access to a specific building, of course it's very expensive to do it because you didn't do it in the beginning, right? So just as it's not necessary for wheelchair users nowadays, for instance, to carry around a piece of plywood if they want to go for a stroll, just as it is not necessary because there's already many cities that have curb cuts. It shouldn't actually be necessary to have a $10,000 piece of equipment, of dedicated hardware. There would be no need for that if mainstream devices such as the Android platform, such as iPhone, smartphones, tablets, all those products, if those products were accessible, then there wouldn't be any need for a $10,000 piece of dedicated hardware, right? So yes, if you look at it from the perspective of the context in which things are already inaccessible, there's a lot of justifications for that, right? For not actually making it accessible. But if you step back and realize that these barriers are actually caused by the fact that in the first place it wasn't made accessible, then you realize what a significant gap that can be, and what a significant gap this kind of context can create. And I'm going to talk a little bit more about this as I get into the talk. So we at the Inclusive Design Research Center decided, well, this is not acceptable, right? This is not the way it should be, and we tried to figure out how do we do it so that people with disabilities, say power wheelchair users, can access the same functionality, the same power that is expected, that any of us expect from mobile devices, from the new technologies, from information technology. How do we do it so that they can access it without having to go to these bizarre extremes of charging thousands of dollars and creating segregated spaces and markets that play by their own rules and all that? And we decided, or we realized at the moment, that the emerging technologies, emerging mobile technologies, offered significant opportunity for solving all these issues. So we went to all of them at the time and looked at which of these platforms can provide the most natural built-in way of accessing or tapping on all that potential without having to create our own thing from scratch, right? So right from the beginning, we realized there was a couple of devices or a couple of platforms that we could just not use. They were still trying to get their act together. It was just impossible to consider. We later considered the iPhone and iPod platform, the iOS mobile platform, but it was just too, it has too many limitations for what you can do as a developer. At the time, you couldn't run background processes. You couldn't enhance or substitute the input method, which was essential. We wanted to be able to control the phone or control these devices through alternative input methods, not just the touch screen or the keyboard. We wanted to be able to allow people who can't actually use their hands to control these devices. So for that, we needed to have a way to either enhance or substitute the input method. And at the time, the iOS simply didn't have that option, didn't offer that option. We also looked at Java. There were some neat things that we could do written in midlets, but at the end of the day, midlets run on foreign operating systems, and if we didn't have access to those operating systems, we wouldn't be able to achieve what we wanted to achieve. Symbian was interesting. They were also going through a big transition, and at the end of the day, they also, it was possible to substitute the input method and enhance it, but we will have to deal with upstream pushes, right, to their project, and it was unlikely, or we didn't know whether we were going to be able to influence the development of that project at all. The Memo platform was very, very attractive because it was already open source. It was based on Linux. It had all the right ingredients that allow these kinds of platforms to be enhanced by the community. But all of a sudden, they decided to drop keyboard access to their platform. There was no more focus highlighting. There was no more basically keyboard access, right? So there was nothing we could do for the first version of Migo that came out of that. The accessibility team at Research in Motion, being Canadian, was very, very eager to get this working on their platform. We had a few technical discussions about how to do this, and we ended up with a plausible solution. The only disadvantage was we had to rewrite the entire input method from scratch, and we didn't have access to the built-in input method on BlackBerry devices. We would have to be a separate application and try to do a bit of hacking to hide their input method and have ours come up to the front. So it was possible, but it was a bit more than necessary. The work that was a bit more than what we were looking for, and finally, the only real option for achieving this ended up being Android, and that was a very obvious choice by the end. So the Android platform could at the time and still can or still allows background processes to run on the device, which are essential to be able to get information from alternative devices, which is what we wanted. We didn't want to have to ask the alternative device every time, poll it and say, hey, are you still there? Are you okay? Do you have any news for me? Android would allow us to just simply send notifications directly to the operating system and go with it. We were also, like BlackBerry and Symbian and Memo, we were also able to either enhance or substitute entirely the input method. But the real thing that made us go for Android was we didn't have to start from scratch, right? So we could just fork the input method that was built into the Android platform, and then add the features that we required, and then republish as a new application, which is actually what we ended up doing. And the result, if this animation works, is the Tecla Access project. And the Tecla Access or the Tecla Access system, this system is composed of two, or it has two main components. And I'm gonna, I think I forgot my my laser pointer, but I'm going to show you here with the pointer in the screen. One of the components is a hardware component. It's called the Tecla Shield, and the other component is a free app downloadable from the Android market right now. We just pushed the latest version on Wednesday, which has a lot of really neat features, and basically what the application does is well, I guess I'm going to have to, I'm going to go the other way, actually, because it's a little bit awkward to go backwards. So we have a user, say, in a power wheelchair, and something I should mention here is there's a lot of resources that go into making sure that a power wheelchair fits the user. There's a lot of things that you know don't usually think about, like seating, for instance. So these are people that are going to be sitting on their wheelchairs for 12, 14, 16 hours a day straight. Many of these people don't have the ability to adjust. You know, when one side of their leg gets tired, you know, usually if you're sitting around, you're moving around, you feel a little bit uncomfortable, you change positions. Well, this is not the case in many cases with people with disabilities. So the sitting, there's a lot of attention and resources and money and people that are invested just in making sure that people won't get what is called pressure sores, which is, you know, you stay too much with an unevenly distributed weight on a single part of your body, and then the blood flow gets cut off. And then there's infections, and then, you know, there can be even open wounds. So that's serious stuff, right? So there needs to be a lot of work invested in making sure that doesn't happen. There's also a lot of work in making sure that whatever interface the person uses to drive the wheelchair is the best they can do. So some people, for instance, have difficulty controlling gross movement. Say if they were to go and try to push a button, there will be all sorts of unwanted movements, and then hitting the button is like a crapshoot kind of thing, right? That sometimes they hit it, sometimes they don't. So some of those people will use their heads, for instance. So there's going to be head arrays mounted on the wheelchair, so that they can, with the movement of their head, drive the wheelchair around. Some of them will use shoulder switches, tongue switches, sip and puff switches with a straw, and they just blow on it. They blow harder, and the wheelchair does something else. So there's really quite an art form to actually figure out what works best for these people, and this is all done. In most of the developed countries, at least that I know of. In Canada, a lot of this cost is subsidized by either government agencies or non-for-profit organizations. But the point is, there's literally tens of thousands of dollars that go into this, and hundreds of hours or man hours going into making sure that this one person is going to have the ability to drive around, right? Because mobility is one of the first and most essential needs that you will have as a person with a moderate to severe mobility impairment. And then once it's all done, in many cases that's all you can do, right? You have the perfect interface fitted to your body. You have a wheelchair that you're driving around with a 12-volt car battery on it, and that's it, right? You go in front of an ATM and you can't use it. You go in front of an iPad or an Android device and you can't use it, right? So we were wondering, well, can we tap into this effort, right? There's a lot of people that have already solve that problem. So why don't we just tap into that, provide some kind of interface, some kind of mediator, and then people can just do whatever they want to do, like anybody else, right? And this is what the Tecla Access project attempts to do. So we see here a power wheelchair user, what you can imagine to be a power wheelchair user, and the Tecla Shield is connected to their power wheelchair, or can be connected to a power wheelchair. It can also be connected to standard on-off switches like this one. This is a very standard switch that occupational therapists in rehab centers all over the world use. This is actually a sample, one of the latest prototypes of the Tecla Shield. And so the Tecla Shield allows these people to control the device with the interface they're already familiar with or they already have, right? So there's no need to fit anything else or create any other special equipment. You get the Tecla Shield, which is a Bluetooth device, and then via Bluetooth, the signals are transmitted to the app that is running on the phone that has a background process reading the Bluetooth input. And then it uses that to allow people to control the phone with as little as a single switch. So I can actually control the phone, and I think this is connected. Yeah. So I can actually control a phone with a single switch. And this is significant because, you know, single switches are probably the minimal unit of access in mobility impairment. So there's you know, no matter how severe the impairment is, in most cases, there's going to be a way to fit at least a single switch, right? Now, it's a little bit hard to show you how that works. It's easier to show you in person. So we have a setup here, and I can show you later after the talk, perhaps. So what I'm going to try to do is do it with the emulator, with the Android emulator, and oops, let's see what's going on. Okay, so I have a stock Android API level 7 here running, and let me see if I can. Oh, it doesn't have the application. I'm gonna install the application just very quickly. Where is it? Actually, I want to run the stock 5 because I know that one does have it. Let's see. Do you have any questions, any comments until now? Are you comfortable? You're following the talk? Yeah? That's good to know. Okay. Yeah, so what I'm going to do is I'm going to show you the application on the Android emulator, as I said. The application itself has a mode called the full screen switch mode, which basically turns the entire screen into a single switch. So we use it for demoing it and for testing. In practice, this is not necessarily a very good idea. These switches get abused pretty badly. So it would be a bad idea, well, in many cases, it would be a bad idea to just have the phone there as a single switch for someone to use. But it does go as far as showing how this can work. Oh, does the emulator reset the memory? I guess it does. Okay, so let's I'm going to install it quickly on the stock 5. Let's see. Okay, so it's installing now. It's done. So there's going to be a. I'm going to use the mouse here. There you go, Tecla Access. It's not showing the icon for some reason. But then the next thing is I go into settings. I go into language and keyboard. Tecla Access, enable it. And then I have to go and select it because it's an input method, so I have to substitute the stock input method. Sure. And of course, as it should happen, maybe I'm installing the wrong version. Okay, so let's try that installation again. Oh jeez. Oh, it's not. Let's try that again. Refresh. There you go. So we said stock 5. There you go. So I go into stock 5. Let's see. What's going on? I'm gonna try just one more time. Let's try with stock 7. There you go. Okay, so again I go into settings, language and keyboard, select the Tecla access input method, and then substitute the substitute the input method. Here you go, Tecla access, and we're in. And then the last thing I want to do is go into the Tecla access settings. And then activate full screen switch mode. So there you go. So this is how full screen switch mode looks like. And as you can see, there's an always on-screen keyboard at the bottom. The keyboard is self-scanning. The self-scanning feature has been activated. And now, whenever I want to do something, I just have to wait for the highlight to get there, to get to the command I want to send, and then press anywhere on the screen. So if I want to go back to my home screen, for instance, I will wait until the back button is highlighted, and there you go. Then I wait maybe for the down arrow. I'm going to try to open the browser. So it's highlighting. And then I wait for the OK highlight, hit it, and now the browser is opening. Right? So this is all using a single switch. Even in the browser, I don't know if I don't have a wireless connection now, so it's not going to do much. But even in the browser, I can use this same. Oh, I have a monitor here. I've been trying to. I can use this same feature to go and browse all of the active links. So you can see, even there in the 404 page, I can go into the link itself, and then just keep browsing, right? From there. I'm going to go back now. Maybe to the phone application. So again, this is all using a single switch. I go into the phone application, press OK. I'm doing it slowly enough that I know I'm not going to make any mistakes. The actual users of this kind of application tend to go really, really fast because we have to remember these are interfaces that are specifically designed for them, the interfaces they use, the switch interfaces they use. I made a mistake there, so I'm going to go back. And then I started dialing the phone number, for instance. So I'm just going to do a 647 thing, which is the area code for Toronto cell phones. There you go, 64. Of course, it's going to be easier if I already have my contact in the contacts list, and I can just go to the list and go down, 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 and select it all, right? But that's a basic idea. This is just so you get the idea of this. And as I said, we can try it out after the talk with the actual device. And then we're gonna move on to the next slide, and I'm going to show you a video of the first user of this, the first actual user of this system. Eric Wan is a engineering master's student at the University of Toronto. He was actually the first student that started the code base as part of the Google Summer of Code. You can see there how he's, well, the video is not great quality, but you can see there how he's moving the highlights in the keyboard. In the first version, the highlights were very faint, gray. Now as you saw in the emulator, we made them a bit more clear. And he's basically, in that particular case, he's trying to open the app drawer. So he finally gets it open. And yeah, that's actually not single switch, because if you probably saw him backing out, and there's no self-scanning, so he actually has access to 3 switches, I believe, and he drives his wheelchair with a sip and puff interface, so he blows and sucks for the switches to be activated. There's soft shift, soft puff, hard sip, hard puff. So in total, he has access to 4 switches, and I believe he has a separate head switch, if I'm correct, to switch between the wheelchair and the phone, right? Because that's the other. You don't want the wheelchair to go while you're using the phone, of course. And then once he's in the application, he goes in and starts typing hello, I think. I don't remember exactly what he was typing there. It's not very clear. But that was the first prototype. This was completed after the Summer of Code 2010. So about a year ago. And since then, that's Eric Wan again. He was starting the masters then, I think. He's going to be done next year. And in 1 year, we've come all the way to this. This is the first logo you saw. There is a startup company that is or has been set up to commercialize this technology. It's open source technology. The hardware is based on the Arduino prototyping platform. This particular video shows Carolyn, who's an intern in a magazine. A company that edits magazines, and she's talking about her experiences and her hopes as the first beta tester of this particular device. This one is particularly interesting because even though Eric Wan was actually using a straw and touching the straw to be able to control the phone, Caroline doesn't actually touch anything because her head switch array is composed of proximity sensors. So basically, she just leans to one side and or to another, and that's how she activates or she has access to the phone. So if you think about the initial slide that I show you, the couple initial slides that I'll show you, I think this is pretty close to something like telekinetic control of Android, right? Like Caroline is absolutely not touching any interface to be able to control this. You can see here again in the first session where we were trying to well, she was getting used to the interface and getting used to how to control it. She uses two switches. She does use cell scanning. The second switch is for canceling whatever action that she did that she did not want to do, for correcting mistakes. And so I'll leave that video like that. And then I'm going to go back to the slides. So this is just a sample of the kinds of things we've been hearing. This is the mom of one of our beta testers. She came into the office the other day, and I mean, it's not. It's great, I guess, to have someone like her with a grin in her face, saying, you know, my son texts me now every day from school. That's Carolyn. I feel that Tecla has given me even more independence. And there's also one of the rehab engineers that we work with at the Blue Review Macmillan Children. Actually, it's not Blue Review Macmillan anymore. Holland Blue Review Kids Rehab Hospital in Toronto, and you know, him talking about what he thinks the hope for this kind of technology is. Now, beyond this point, I really want you to know that this is, you know, regardless of what I say next, this has definitely been possible in a great part because of Google and because of the Android team, right? So the Android team, is there anybody here from the Android team? Not here? Well, you should let them know. Their work has made this possible, and no other platform, no other company has been able to provide these kind of facilities to do this. With that said, there are some issues, and this is actually why I came I came here. I'm more interested in sharing what are the remaining barriers that exist. This is a screenshot of menu options that is coming on top of the input method, so you can't actually see the keyboard there. This is the standard behavior for any Android platform. The problem is not only that users can't see the keyboard, but that the keyboard events are sent to the activity in the background or in the back behind the keyboard. Therefore, this particular menu is completely not accessible to these users. And just to give you an analogy of what that means, you know, with the Android platform, users are able to browse the launcher and open applications, and maybe, you know, open the browser, follow a few links. So there's a lot of work already done here to mitigate that first significant barrier. Then you can even go further, and you know, there's lots of things. There's a lot of barriers that this solves. But then at the very end, we have a little bit of a problem there, right? So there's no way to get around that, and it's just the way it is, right? This is another example. This is actually a little bit worse because at least the other one you can somehow escape from. This one is a temporal breaking of the phone. Alert dialogues and spinners also come on top of the keyboard. So when they appear and there's no way to tell or to predict when they will appear, the user is effectively locked out of the phone, right? There's no other way to do it. In the software, we have workarounds for this, but it's not a fix, it's a workaround. We basically call home, allow them to call home if they press a switch for a really long time, and then it just goes back to the launcher. But this particular pop-up alert dialog basically has, or is the equivalent of, you know, it's great, I'm going to go down, I'm going to go in my ramp, and I'm so glad that this thing is accessible. And then all of a sudden, there's no way to go. And in this one, you can't even go backwards, right? You're just stuck waiting for someone to get you out of that trouble. All in all, however, if I was to do a completely arbitrary scale of, whether this Android system is either a paperweight or all the way from a paperweight to awesome, I would still put it very close to awesome, right? Like it's great. It's just great that people can make phone calls, can go into Twitter, do whatever the hell they want to do, same as anybody else would, right? There's a few other minor issues, but of course this is just the first try, or at least with the Milestone. In Milestone was branded in Canada was branded Milestone. This is a Droid here, I guess. That was the first really successful, or what people see as the first really successful commercial example of the Android platform working on a mainstream device, and it's also the first try of something close to full accessibility, right? So to get that high that soon is pretty impressive. The later releases, Froyo, Gingerbread, did a few fixes on a couple of applications. So, for instance, Gmail. If you use Gmail in the Droid, it was not possible to look at different accounts because that was part of the options menu. It was also not possible to go into different labels because that was also part of the inaccessible options menu. But then there was a fix, and there was the Android team created a nice Android bar, and then you had your labels and your accounts at the top, and it was all highlighted and keyboard accessible, so people could use the phones. And the other thing is something that hit Android in general, I think, and it was definitely not Google's or the Android team fault, which is the platform exploded, and there was all sorts of broken builds out there, right? The wireless carriers in Canada said, "Oh, we don't like the designers at Google. They make ugly interfaces, so we're going to make our own, and it's going to be great." And that's great, except they broke everything that the accessibility team had worked on. There was no highlighting. There was no keyboard accessibility. So it happened first with the Samsung Galaxy, the Sony Ericsson phones. You could make a call, but you can't actually hang up because the button for hanging up is not highlighted. There's all sorts of issues. We had LG phones throwing fits with when Bluetooth was shut off because they wouldn't close the Bluetooth socket cleanly. So the phone will do all these crazy things before killing the socket. All sorts of workarounds we had to write in the software. But if you stuck with the Google evaluated Nexus S, for instance, you still had a pretty good experience. There was a few issues here and there, but that problem of the fragmentation, broken builds, just really impacted the whole experience. So I would put it a little bit lower, right? It's not, in this particular case, it's not Google's fault, and it just happened to be like that. The problem is, I was really excited about the ice cream sandwich release this week, and I was very eager to see the keynote. Was it this week? Earlier this week, I think, yeah. And I saw the video. In the video, people mentioned something about accessibility. They mentioned that there were enhancements, and I was really excited because I said, well, they're so close, right? Google and Android are so close. And if they are mentioning enhancements, then I'm pretty sure they're already there. For making sure that those pop-ups go behind the keyboard, there's actually just one flag, right? It doesn't cost too much. It's not too much trouble to just turn it on or turn it off. Maybe they realized it. We've been busy working on this project. We haven't had time to spam you with bug reports and all that, but maybe they already realized by themselves. So I went ahead and tried the ice cream sandwich build, or oh, this one did like it. I went ahead and tried it, and the first screen that I encounter here is the launcher. We have highlighting, not as great as the previous versions, but it works. People know where they are. I go up. I don't know if you notice, I'm already in the Google bar, in the Google search bar. That highlighting is a little less obvious, but people maybe can get used to it. That's not it's not the end of the world, right? So let's go into the app drawer, and then I'm going to try to select an application. And actually, I have no idea now where I am. Well, I guess I am in the apps thing. I'm going to go into widgets, see what I can do there. Nothing. No highlighting. Really? Well, maybe it's just low. I tried it at home a few times, and the highlights never appeared. I don't know, like, I really felt, how do you say it when you feel there's nothing you can do? You're at the mercy of someone else? There's a word for that in English. And this is basically what happened. So I did a bunch of tests. The app drawer, as you saw, is unusable. There's custom views. Now some of the settings, for instance, in the keyboard, the keyboard options were a little bit awkward before because they were divided in two. You had to first select it in the checkbox and then go to the settings, and the settings had the same name, and people got a little bit confused. So the ice cream sandwich solves that problem really well, because then they create a custom view that has the checkbox, the name of the keyboard, and the icon for the settings on one side, right? Great. If you actually go into that with a keyboard, you can't actually access the settings. You can't actually uncheck the checkbox. So that's a lot of those setting boxes are unusable now. There's broken apps now, and those are the built-in apps. So if I tried going into the contacts manager, I think it's called People now. You go into People, and then the first thing it asks you is to create your profile. There's a little button, and yeah, if you touch it, it works. If you try to go in with the keyboard again, it doesn't work. It highlights, you press OK, which is the D-pad center event on the keyboard, and nothing happens, right? So that's now unusable. The one thing that it seems to be aiming to fix, though, is the broken builds, right? Apparently, my understanding is that the builds of Android should be a lot less fragmented now. Well, I guess we'll have to see. But this is the first time that this is actually something we can't use, right? Like we went all the way backwards. So now all this excitement about being able to control the phone, about people in wheelchairs being able to telepathically or telekinetically command their phones to do what they wish is gone, right? In this particular version, and I can't help to think. I know there must be a plan for this. I can't imagine there's not a plan for this, but I can't help thinking: was this just an accident? But this accessibility level of accessibility really just accidental? Like maybe the Android team didn't even know that. And I talked to my supervisor about this, and my supervisor said, make sure to let them know that there's others out there that are starting to get it, right? The kind of work in accessibility that the iOS 4 did for people with visual impairments was phenomenal. And now in iOS 5, they're mentioning switch access, right? So now we're, what's going to happen? And this one here, apparently, the green one was accidental, right? This one is purposeful. So I wonder what will happen. And the question is, what do you want it to happen, right? What does the Android team want it to happen? I meant to call this slide it's called silly math, but it's more like the silly arguments. I could stay here and talk to you, or I could talk to you now about the hundreds of thousands of people just in the US and Canada who are depending on this kind of technology to be able to eliminate the barriers that currently exist to mobile devices. I could also talk to you about the fact that historically, from anywhere from Alexander Graham Bell to Ray Kurzweil, any of the developers any of you as developers who work on technology that solves some kind of accessibility problems has a really high probability of creating the next best technology. That Ray Kurzweil invented the flatbed scanner, trying to figure out how to read characters from paper, right? So that people with visual impairments could read them. Alexander Graham Bell invented the phone, trying to figure out how to, or trying to understand how the human ear works to try to help some deaf children in a school that he was working at. And the one that I think is the silliest one of all, you will make some money doing this, right? Like there's going to be more people buying or using Android just because it's accessible, right? But I just feel these kinds of arguments are very silly. I was talking to a PhD student at the Ontario Institute of Studies in Education. It's called. They have a human rights program there, and I started with a very bad question, which is usually the worst question you can ask a PhD student. I asked, "What are you doing?" Right? And I was waiting already for the full hour, just nodding, not having any idea what he was going to say. And he said, "Well, do you know? You have heard of this term, systemic racism, right? Have you heard of that term?" And I said, "Yeah, I've heard that term." Well, I'm trying to figure out what makes it systemic. Right? I'm trying to figure out what is it that makes racism systemic, because we all know about that term, right? But what is it that actually makes it systemic? And that's why I feel these arguments are silly. It's like to me, it's like trying to tell the Montgomery City Transport Authority that they're going to make a few bucks if they let Rosa Parks sit wherever she wants, right? Like it's just like, should we really? Are we really doing this these days? Is it not just the right thing to do to make sure that these things are accessible? And it's not like there's a lot of work to be done. Remember, the Android team was already here. Very close to awesome. I want to see it there, and and I'm sure and I know the Inclusive Design Research Center wants to see it there, and I'm positive Komodo Open Lab, the startup company that was created to commercialize the technology, wants to see it there too. And it's not, it doesn't seem like it's too hard, especially if you were already there. So I'm going to talk about, and I want to close off with an example of just beautiful inclusive design and beautiful design that is existing now in the Android platform. These are a couple of screenshots you have on what is it, my left, your left too, yeah. You have a screenshot of the Android of the Droid phone, which is to this day the one that works best with this kind of technology. And on the right you have an example of voice actions, the voice actions and voice search app. And the very interesting thing about voice actions is that it's an alert dialog that actually comes below the keyboard. I have no idea why it comes below the keyboard, but it's actually a fully functional. It makes it fully functional. It makes it fully functional with alternative inputs. My guess is the Android team is trying to anticipate the market of the distracted driver, right? So drivers are people, like people in wheelchairs, that cannot handle the phone. They're in a context, in a particular situation, in which in some cases it's illegal to actually be holding the phone. In other cases, they just can't because they should be paying attention to the road, right? So if I'm trying to create an application that allows them to send an email with their voice, for instance, I have to make sure that they can use it without ever touching it, right? And that's my guess of why that dialogue actually exists and it works the way it works. So if you want to go for it, if you want to let the Android team know, that's the beauty of inclusive design, right? You design or you try to design for people who can't handle the phone, and you end up benefiting a lot more people than you think, right? And just to close off, and I guess it just follows naturally from this, disability is still nowadays is considered some kind of deficit or illness, but it is very obvious. I think, as far as I can tell from what I try to say here, it's very obvious to me that it is more the result of basically inaccessible environments, and most of all discriminatory contexts, right? So, you know, that's about it for me, and hopefully, both of us, Mauricio and I, are completely committed to working with whoever we can work and whoever is necessary to make sure that Android goes all the way to the awesome side of the spectrum, right? So, thank you.